if we have two sets, set A and set B, and let me draw out the boundary containing the elements in A and that in B. And let's say we have the elements 1, 2, 3, 4, 5, and 6 in set A, and we have the elements 1, 4, 9, 16, 25, and 36 in B. Now let's try to look at the relationship between these two sets. Now we're going to assume that we have a mathematical machine in between these two sets, such that this mathematical machine enables us to relate the two sets. Now this machine works in a way that it takes in elements from A and refine it and brings out a corresponding element in B. Now, and it works in such a way that each element in A is corresponding to a particular element in B. 2 is associated with 4, 3 corresponding with 9, 4 with 16, 5 with 25, 6 with 36. So this mathematical machine takes in an element from set A and refine it, brings out element in set B. This mathematical machine is called a function. It could be denoted with the letter F, G, H, and other letters like that, etc., etc. Then what's happening here is that the function, which we called the mathematical machine initially, it takes in elements from set A. So set A, the elements in set A are serving as input. So set A itself is said to be the domain of the function. Set A is said to be the domain of this function. Now, and this function outputs elements in set which are present in set B. So set B is said to be the codomain. Set B is said to be the codomain. Now, the domain of a function can still be written as in this form. Domain of the function is set A. So set A serves as input. So set A contains the inputs. So of course, let's actually look at what is actually happening to the numbers that are in set A. What is happening to them when they are being refined? Now it looks as if, look at 1. We have 1 here. Then we still have 1 here. But here we have 2. Now we have 4. It looks as if it is being squared. So 2 squared, we have 4. 3 squared, we have 9. So what is actually performing this operation is this function. We have 4, we have 16. So 4 is being squared, we have 16. We have 5, we have 25. We have 6, we have 36. So what this function is actually doing is that generally this function is such that it takes in element from A and outputs the elements in B. So this is how it is written mathematically. But what this function is actually doing here particularly is that if we associate all the elements in A with X, with the letter X, let me use this color, with the letter X, and that means it takes in X and outputs X squared. So this is what this function is actually doing. Alright, so this function will be written mathematically as f of x, where x is serving as the input, then we have x squared, which is the output. So this is the function itself. All right. Okay, let's see. Now we could represent this f of x with another letter. We could say let it be y. Let me clean up some space. Okay, let me change color. Now we could say let the f of x, we could let f of x be y. That means now we have y will be equal to x squared. Now since x is the input, x is called the independent variable. Independent variable, while y, which is the output, is called the dependent variable. Okay, now x is independent variable because it is the input, while y, which is the dependent variable, is the output because its values depends on the value of the input, which is x, which you put in. When you put in 1, it gives you 1. When you put in 2, it gives you 4. All right, so let's consider, let me clean this up. Okay, now let's consider a set example. Now let's consider not a set, but a function f, such that this function takes an element from real number. We're actually restricting it to real numbers for sake of simplicity. So it takes in elements from real number and also outputs elements that are real numbers. All right. Now real numbers are These are numbers such as 1, 2, 3, pi, e, which is the Euler's number. You see, so the real numbers are infinite. A minus 1, minus 2, 0. In fact, we have infinite numbers of real numbers. Infinite numbers of real numbers. Okay, so real numbers contains elements that ranges from negative infinity to positive infinity. All right, so we're going to consider a function. Rather, we're actually restricting it to a function that takes in elements from real number and outputs another element which is also in the real number, the set containing real numbers. Okay, all right. So let's consider a set f of x, which is equal to x squared plus 1 over 2. So let's consider this function not a set. This is not a set but a function. All right, so let's try to take elements in real numbers and input them. So let's put in x equal to 1. So let's see what f of x equal to. So we have f of x. Now since we are putting an input of 1, which is the x, so we put in 1. We are evaluating the function at 1. So we have the x squared, that means 1 squared plus 1 over 2. 1 squared is 1 plus 1, we have 2, then 2 over 2 is actually 1. So at s equal to 1, f of 1 is equal to 1. Equal to 1. So And let's put in x equal to 3. So we have f of 3 will be equal to, we have 3 squared, in this case 3 squared plus 1 over 2. So we have 3 squared. 3 squared is 9. 9 plus 1 is 10. 10 over 5 is, 10 over 2, which is 5. And so we have 3 squared, 9 plus 1, 10 over 2, that is 5. So for x equal to 3, we have f of 3 equal to 5. So we could still put pi. Let's put x equal to pi. I'm running out of space. X equal to pi. X equal to pi. So we have f of pi. Evaluating the function at pi. So we have pi squared plus 1 over 2. So for f of for x equal to pi, we have f of pi equal to pi squared plus 1 over 2. All right. So let's consider another example. All right. So let's consider f of x, which is a function which takes in elements from real number and also output elements in which are present in real numbers, a set containing real numbers rather. All right. So we're actually restricting it to real numbers. Okay. So this function is given by f of x equal to x squared plus 2. So let's try to evaluate this function at 8. Let's put in 8. So we have f of 8 now be equal to 8 squared plus 1. 8 squared is 64 plus 1, we have 65. So for x equal to 8, the function is 65, which is the output. So for an input of x equal to 8, we have an output of 64. So let's put in another input. Let's put in 3. So f of 3. We have 3 squared. The function tells us to square the number, then add 2 to it. That is what is happening here. Square the number and add 2 to it. So we have 3 squared plus 2. 3 squared is 9. Plus 2, we have 11. So for an input of 3, we have an output of 11. So we have x equal to, let's put in another value. Let's put in 12. So we have f of 12. So we have 12 squared plus 2. 12 squared is 144 plus 2. We have 146. All right. So it looks as if for each input x, the value gives the function gives exactly one output. Okay. All right. So let's consider another example. So let g of x equal to x squared minus 3x plus 1. Of course, I told you initially that a function can be represented by f, g, or h, or other later, but the frequently used ones are g, f, and h. All right, that was why we use g of x here. All right. Okay. So we let g of x equal to x squared minus 3x plus 7. So let's evaluate g of 10. So g of 10 will be equal to, we have x squared now, which is 10. Then minus 3 times x. What is x? 10 plus 7. 10 squared is 100. 3 times 10 is 30 plus 7. Alright, so we have 100 minus 30, 70, then plus 7, we have 77. So for an input of 10, we have an output of 77. Okay, so we have evaluated number 1. So let's do number 2. Okay, so we are asked to evaluate g of b plus 1. G of b plus 1. So we're going to impute b plus 1 in place of x. So here we're going to have this equal to, we have x squared. What is x? B plus 1. Then squared, x squared. So we have minus 3x. What is x? B plus 1. Then plus your 7 there. So I'm going to evaluate this. Let's just do some algebra. So we have b plus 1 squared. So we have b squared plus 2b plus 1. That is this expression here. So b plus 1 squared is equal to b squared plus 2b plus 1. Then let's multiply this one out. So we have minus 3 times b, we have minus 3b. Then minus 3 times 1, we have minus 3 plus 7. So we have b squared plus 2b minus 3b is minus b. Alright. So we have plus 1 minus 3, which is minus 2. Minus 2 plus 5, which is, minus 2 plus 7 is plus 5. Alright. So the function, when you put in an input of b plus 1, we have b squared minus b plus 5. Alright. So we have evaluated number 2. So let's look at number 3. So the input now in this case is r squared. So anywhere we see x here, we put in r squared. So we have this function, we have r squared. We have x squared minus 3x plus 7. What is x? R squared. R squared. Now using the index law, you're just going to add the powers. So we have 4. 2 plus 2, we have 4. So we're going to multiply the powers. 2 times 2, which is 4. The index law. So we have r raised to power 4 minus 3 times r squared, which is just 3r squared plus 7. So for an input of r squared, we have an output of r to the 4th power minus 3x squared. Minus 3r squared plus 7. Alright, so we've evaluated number 3. So let's go to number 4. Alright. So we have g of x plus h. So anywhere we see x, we replace it with x plus h. So we have x squared from this, x squared. What is x? What is x? X is x plus h in this case. So we have minus 3x. What is x? X plus h. X plus h plus 7. So we have x plus h squared. So I'm going to multiply this out. So we have x squared plus 2xh minus h squared. Then multiply minus 3 by 3x by x plus h. So we have minus 3x, then minus 3h plus 7. Alright, let's see if we can simplify this. Okay, that is just it. So we have, this is the answer. So for an input x plus h, we have an output of x squared plus 2xh minus h squared minus 3x minus 3h plus 7. All right, so we have done number 4. All right, so let's clean this up. Okay, so let's do number 5. Number 5. Before I do number 5, try to pause the video and try this out. All right, okay, let's do it now. So we have g of x plus h minus g of x over h. All right, this is somehow rigorous, but let's see. Okay, let's see. So we have g of x plus h. So in place of x, we see x, we put x plus h. So the first one, we have the function, which is x squared minus 3x plus h. So anywhere we see x, we put in what? X plus h. X plus h, we have squared. Then minus 3x, what is x? X plus h. Then plus 7. And we now have minus g of x. What is g of x? Of course, this is g of x. So we have minus g of x, which is x squared minus 3x plus 7 over h. So let's do some algebra. Now x plus h squared is actually x squared plus 2xh plus h squared. So this expression x plus h squared is equal to x squared plus 2xh plus h squared. Then minus 3x times x is, minus 3 times x is minus 3x. Then minus 3 times h is minus 3h plus 7. So we multiply this out. So we have minus x squared minus x squared. Then minus times minus 3x, we have plus 3x. Then minus times plus 7, we have plus, minus 7 rather. Minus 7. Then everything over h. Over h. That my h there is looking funny. Okay. Over h. That's nice. All right. So let's change color. So we see that x cancel out with minus x. So 3x cancel out with this. 7 with 7. Okay. So let's write the answer here. So we have what is left? We have 2x h plus h squared. Then minus 3. Then everything minus 3h. Then everything over h. Now we could distribute the h such that h cancel out with h here. We just have 2x left there. Then plus h squared over h is just h. Minus 3h over h is just minus 3. So the answer is minus 3. I'm running out of time. I'm going to see you in the next video.